we were talking about these where we left off. I just want to go over these sets, and especially just making sure we have the numbers because we're going to use them in the next couple of pages. I'm also going to write them on my whiteboard so I remember them. But the even, we did non-negative single-digit numbers, so we could start at 0. I told you that 0 is even for this case. I also told you on the diploma they'd have to specify that it was even. And most of the time on the diploma, they just won't use a whole number if it's even, so that you don't have the 0 problem, right? They might say single-digit natural numbers, and then you start at 1, and then 0 is not even an issue, right? Okay. So the even ones you should have had were 0. Ooh, that's a really tick marker. 0, 2, 4, 6, 8. And then whole numbers less than 0, whole numbers start with? Number with a whole, which is 0. Yes. 0, 1, 2, 3, 4, 5, 6. And we didn't put 7 because it said what? Less than. And then odd numbers less than 7 are 1, 3, 5. And once again, we didn't put 7 because it was less than 7. So I'm just going to write these over here for our benefit for after. All right. So we're going to talk about the universal set. Like I said, this is very beefy in definitions. It's the only unit that is, and I just started off with it because I do think it's the nicest unit. At first it seems a little weird, but as you go along, you're like, hey, that's not so bad. Okay? So we have the universal set. Within the context of any problem in set theory, there generally is some larger set that we have in mind. So sometimes the universal set might be this classroom. It could be like all the people in here. You're the universal set, and I can only choose people from in here, right? Or the universal set could be our school. And you look at all the people in the school, and in the school, you can only choose people from that, okay? So within the context of any problem in set theory, there generally is some larger set that we have in mind. We refer to this as the universal set, okay? It is the set that contains all of the elements under consideration and relevant to the problem. So state the universal set for the one above. So the universal set is a U with 2 little ticks on it. It kind of looks like a horseshoe. Okay, that's the universal set. Make sure no phones are out. Remember, I said if you work really hard in class and you don't have your phones out, you don't get homework. It's a win-win. So universal set is like the horseshoe. And we look at the previous example. The previous example, we have to look up there and we have to say, what parts of this example were the only numbers we were allowed to look at? So it is non-negative single-digit numbers. Non-negative single digits. What's a non-negative single-digit number? Where do we start at? 0, and then we went to 9. We went to 9. Non-negative single digits was 0 to 9. We agree? So the universal set for this were the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those were the options we had. Because the universal set, as it says up there, is some larger set that we have in mind that we're only allowed to do, right? So I couldn't put a 10 up there because a 10 was not a single digit. I couldn't put a -1 up there because it said non-negatives, right? So the only numbers we were allowed to list in E, L, and O came from the universal set, the numbers 0 to 9, right? Even though odd numbers less than 7, I could have put a -1 here. I couldn't actually, because my universal set limited me to non-negatives. Okay? So the universal set is the biggest set that you could choose from, and no other numbers outside of it, or no other people outside of it. So if I was doing a universal set being this classroom, and I asked you for all the people in social, I would only count people in this class in social, because you're the universal set. I wouldn't go out to the world and say, hey, Mr. Clay, how many people are in your social class? Because I would only be looking at your class as the universal set. Okay? Now, subset. Can you go to your formula sheet for a second? I want to remind you what's on your formula sheet. So on the very right bottom, it's called logical reasoning. Those are all the formulas that you're given for this unit. So the very right bottom. Okay? We haven't talked about any of them until this very moment. We're going to talk about the subset. Do you see how it's like that sideways U? Do you see that? So if you see a sideways U, look at the bottom right, a sideways U, it tells you subset. So if you see a sideways U on your test and you're like, oh, crud, what's that? Go to your formula sheet, it says subset. You're like, oh, right. Okay? You need to know what's on your formula sheet to help you. So what the heck is a subset? A subset is that sideways U shape, just goes like that, or kind of a longer C. A subset of a set is a set that contains some, or all, or possibly none of the elements from a previously defined set. It's a lot of words. Some, or all, or possibly none of the elements from a previously defined set. So, let's talk about this class. Okay? We're going to say the set of elements is this class. All the people in this class. You guys are the set. Okay? A subset of this class could be the people all in social. Can you put your hands up? If you're in social right now, put your hand up. Okay, you would be a subset of this class because all of you are in social and you're in this class. So a subset of a larger set, in order to be part of the larger, a subset of the larger set, you have to be all contained within it. So if I went and brought Mr. Clay's class in here, and you guys, you all put your hands up and they put their hands up, that would not be a subset of this class because you're not all contained within this class. Some are in Clay's class, right? So a subset is a smaller set of the larger set. A subset of this class could be, okay, if you're in Math 30-2, put your hand up. Okay? You're also a subset of this class, and that throws people off because they're like, how are we a subset of this class? All of us are in this class, right? True. So a set can be a subset of itself, and that's the one thing that people forget about. So like if the subset of this, if this class was A and math, we could say A is a subset of A. A is a subset of itself. So it can contain all of the stuff in it, or only a little bit of the stuff in it, and it's still a subset. So here it says, let's go to this. In set notation, the symbol, that sideways C, is used to represent the relationship between sets. So for example, set E is a subset of U. So let's go back and say what they are. So U, you don't have to write this, I'm just showing you. U was the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You don't have to write this, you're just going to pay attention because I got to get you to understand what the heck a subset is, okay? So we're saying that E is a subset of U. E is a subset of U. We can say it with words, or we can say it with a symbol. Well, what the heck was E? That's why I wrote it on this board over here. E was 0, 2, 4, 6, and 8. We agree? In order for E to be a subset of U, everything in E has to be in U. Every number in the E set has to be in the U set. So let's check it out. Is 0 in U? Yeah. Is 2 from the E in U? Yeah. Is 4 from the E in U? Yeah. 6 from the E in U? Yeah. 8 from the E in U? Yeah. What if I made an extra weird set? What if I made a set A? Set A had 1, 2, 3, 9, 11. Is A a subset of U? But almost everything's in it. Like 1 is in U, 2 is in U, 3 is in U, 9 is in U. It's only 11 that's not in U. It's only one thing. Is that okay? No. Every single thing has to be in U. So even if one of the numbers isn't in U, it's not a subset. Does that make sense? So actually, A is not a subset of U. Does that make sense? So the first letter, in order for it to be a subset of the second letter, everything in the first letter has to be in the second letter. Every single symbol, every single number, every single thing. Does that make sense? So let's look at the second bullet. Is set E a subset of set L? So how do we write that? Is E a subset of L? Well, let's write out. E is 0, 2, 4, 6, 8. And L was 0, 1, 2, 3, 4, 5, 6. So we're saying, is E a subset of L? So what does that mean? Everything in E has to be an L. Do I care if everything in L is an E? Nope. I only care this way. Everything in E must be an L. So let's look. So E has 0. L has 0. Woohoo! Winning. This is good. E has 2. L has 2. This is looking good. E has 4. L has 4. This is awesome. E has 6. L has 6. Yay. E has 8. L does. E has 8, but L doesn't have 8. Is that a problem? Yes. Because everything in E has to be an L. Not almost everything in E. Everything in E has to be an L. So since 8 isn't an L, E is not a subset of L. Does that make sense? So we're going to go like this. E is not a subset of L. The slash should go the other way, but I'm not rewriting it. So they say set O is a subset of L. Let's check it out. If O is a subset of L, everything in O must be an L. So O has 1, 3, 5. L has, bless you, 0, 1, 2, 3, 4, 5, 6. Right? Is everything in O and L? Is everything in the O set in the L set? Let's check. 1 is in L. Yep. 3 is in L. Yep. 5 is in L. Yep. O is a subset of L. That's a true statement, right? So then it says, set O is a subset of L, which is a subset of the universal set. What is a subset of the universal set? The universal set has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? The universal set is actually every number. Does it not? So what is a subset of the universal set? Is E a subset of the universal set? Is everything in E from the universal set? Yeah, because they came from the universal set. Remember, the universal set was all we could pick. So E is a subset of the universal set. What about O? Is O a subset of the universal set? Because O has 1, 3, 5. The universal set is that one, and it has 1, 3, 5. So O is a subset of the universal set. What about L? Is everything in L in the universal set? 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Yeah? L is a subset of the universal set. Guess what else is a subset of the universal set? The universal set is a subset of the universal set because it can contain all, some, or none. So every set is actually a subset of itself. That's a trick question that pops up all the time. Like A is a subset of A. So actually, E is a subset of E, O is a subset of O, L is also a subset of L. It just contains everything. So the definition of a subset is it has to contain everything from the first letter has to be contained in the other one, right? Well, everything in the universal set is contained in the universal set, so it is of itself. Okay? On our formula sheet, we also have the empty set. It's a 0 with a slash. It's right here. It's below the complement. 0 with slash, empty set. The empty set is a set that contains no elements. A set that contains no elements. The empty set is a subset of every set. So up here, I could also say the empty set is a subset of the universal set. The empty set is a subset of every set. The notation for the empty set is a 0 with a slash. So for example, the set of all odd numbers in set E is the empty set. How many odd numbers are there in set E? Set E has 0, 2, 4, 6, or 8. Are there any odd numbers in it? No. So the odd numbers in E are the empty set. There aren't any numbers in it. Okay? And we're going to go to the complement of set, and then we're complement, and then we're going to move on to just questions where we don't have to define the whole world anymore. We've got all the definitions. And we use all the definitions. Yeah? Yes. So the complement of a set is the very first one up here. It's A with the little tick. So it's just this. It's written right here. A is low. The complement of set A is the set of elements in the universal set that are not in set A. The set of all elements in the universal set that are not in set A. All great definitions, but what the heck does that mean? So let's look at this one. Write the complement of set E using set notation. So the complement of set E. We want the complement of set E. We agree? The only way we can state the complement of set E is if we have the universal set and E. We need the universal set and E. So let's state that over here to help ourselves. So the universal set is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And E was 0, 2, 4, 6, and 8. We agree? We said E was a subset of the universal set because everything in E was in the universal set. We agreed with that, correct? Well, what we want is we want what's in the universal set but not in E. That's what this means. E complement means the complete opposite of E. So in order to state the complement of something, I need to have a universal set. I need to have a big set, right? So for this class, for example, if I wanted I wanted the complement of the people not in social, what would I do? I'd have the people in social, they could raise their hands, and then everyone else who doesn't have their hands raised would be the people not in social. That would be the complement of social. And when you add the two complements up, when you add the social and the complement of social up, you should have all the kids in this class, correct? Because they're complete opposites. They're complements of each other. So if I want E complement, it's going to be what's not in E, but in the universal set, correct? So 0 is in E, so we can't count it. 1 is in the universal set, but not in E. 3 is in the universal set, but not in E. 5 is in the universal set, but not in E. 7 and 9. You see that? The complement of E is just what's in the universal set, but not in E. Now, if I take E and its complement, I should get the what? I should get the universal set. If I take all the elements in E and I write them with all the elements not in E, I should get the universal set because they're complements of each other, which is like opposites, right? Everything that's in the universal set but not in E is in not in E. So the complement and E should give me the universal set. Let's check it out. So E has 0, not E has 1. E has 2, not E has 3. E has 4, not E has 5. E has 6, not E has 7. E has 8, not E has 9. That's the whole universal set. So I know I'm right. Because they should make the universal set when you put all their numbers back together. Does that make sense? All right, let's look at example 2. Okay, so here it says, consider the following two sets. A equals the natural, what is a natural number? Yeah. Any number above 0. The ones you naturally count, right? The natural numbers are the natural numbers a toddler counts. And where does a not genius toddler start at? 1, right? So this is going to start at 1. Okay, that's what we know. So natural number means we're going to start at greater than 0, which you were saying, or equal to 1, right? So the natural numbers are greater than 0, or your naturally counting numbers. You just need to remember that it's like a natural counting toddler. They start at 1, 2, 3, 4. Okay? Now we need less than 20. So where are we going to stop at? 19. So what are we doing? We say we're going from 1 to 19. That's what we've just decided, correct? That's all the numbers we can look at. We agree? Now it says that are divisible by 3. What does divisible by mean? If you divide by that number, what happens? Yeah.
There's no remainder.
There's no remainders, right? It's just a whole number when you divide it, or a natural number, technically. Okay? So, before we go to do that, let's look at A. A says, explain why the natural numbers less than 20 is a suitable universal set. Okay? Keep that in mind. Why would the natural numbers less than 20 be a suitable universal set? Let's look at B. The natural numbers less than 20 that are divisible by 5. Divisible by 3 is the difference. Divisible by 5 is the difference, but what do they have in common? The natural numbers, what? Kale? Natural numbers?
Are
Less than 20. Both of them have that in common, correct? And if they have that in common, that's a universal set. What did we just say? We can only look at the numbers 1 to 19 for this whole thing. Well, that's what a universal set is. A universal set is some sort of set that you only can look at certain numbers. That's it. So I'm not allowed to use 20. I'm not allowed to use 0. I'm not allowed to use negative 100. Just that. So explain why the natural numbers less than 20 is a suitable universal set. It's because the natural numbers less than 20 are the only numbers allowed for both sets. They're basically restricted. These sets are restricted to the numbers between 1 and 19, right? So to help us out, I'm going to write out the universal set. You might not want to. Trust me, the more numbers you write out, the less mistakes you will make, okay? So I know people are like, 1 to 19, I know what that is. I will always write out my universal set, the whole thing. So I'm going to write up here. The universal set equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Because then I can visualize every single number I'm allowed. So I write that out. The universal set of the numbers 1 to 19. Yeah. Yeah. And the reason why I want to be able to visualize them is it's a lot easier to figure out divisible by 3 if you can literally look at the numbers and figure out which ones of those are divisible by 3, rather than trying to, in your head, go 1 to 19. Okay, what numbers are 1 to 19, and which ones of those are divisible? If you can physically see them in front of your face, it's a lot easier to figure out which ones are divisible. Okay? So here it says, list the elements of the following sets. List the elements of the following sets. So they want the elements in A, remembering that A are the natural numbers less than 20, so these ones, 1 to 19 that I've listed, that are divisible by 3. So we need to go to the universal set and pull out the numbers that when I divide them by 3, I don't get a decimal, or I don't get a remainder. Okay? What's the first one? I heard someone whisper it. Anyone know? What's the very first one that's divisible by 3? 3. Someone said it. Is that you, Mitch? 3. Then, which is the next one? 4 divided by 3? Decimal. 5 divided by 3? Decimal. 6 divided by 3 is? 2. Is that a decimal? Nope, so it's divisible by 3. Then, 9. Then, 12. Then, 15. Then 18. Then I'm going to have you do B. B are the numbers less than 20, natural numbers less than 20 divisible by 5. And then I want the complement of A. What's the complement of A? The opposite of A. So all the numbers in the universal set that are not in A. So I'm going to get you to do B and the complement of A, and then you have to talk to someone beside you and see if you have the same answers. Okay? Try it out. Okay. B are the ones that are divisible by 5, so that would be 5, 10, and 15, because 5 divided by 5 is 1, 10 divided by 5 is 2, 15 divided by 5 is 3. So most people have that. And then the complement of A is literally all of those numbers from 1 to 19 that are not 3, 6, 9, 12, 15, and 18, right? So the complement of A is basically all the numbers that are not divisible by 3. So that'd be 1 and 2, but not 3 because it's listed. 4 and 5, but not 6 because it's listed. 7 and 8, but not 9 because it's listed. 10 and 11, but not 12 because it's listed. 13 and 14, but not 15 because it's listed. 16 and 17, but not 18 because it's listed. And then 19. So most people did it really good. So write a description of the elements of the complement of the set of B in words. So B is the natural numbers less than 20. that are divisible by 5. What would the complement be? The natural numbers less than 20 that aren't divisible by 5. Yep, that's it. That's all the complement is. It's just the negative of it, right? So write a description. So we'd go B complement equals the natural numbers less than 20 that are not divisible by 5. They give us a new set. C. Oops. C is the natural numbers less than 20 that are multiples of 6. What's a multiple of 6? It starts at 6 and then goes up by 6. Starts at 6, goes up by 6, right? So we're going to list the set C. C equals, starts at 6, goes up by 6. So 6, 12, 18, then do I list 24? Why not? It's bigger than 20. We have to stop at less than 20, and it's too much. Too much. So we stop. It's just 6, 12, and 18. Now we're asking some questions. Is C a subset of A? What does that mean? Everything in C has to be in A, correct? And I'm not joking to you. Rewriting the sets near each other will help you out than trying to look at them on different parts of the page. I know it takes a little bit more energy, but it is helpful. So I'm going to write A here to help myself out. So A is 3, 6, 9, 12, 15, 18. Now they're asking us, is C, everything in C, in A? Is everything in C in A? Everything in C in A. So let's look at C. C has 6. Is it in A? Yep. C has 12. Is it in A? Yeah. 18 has is in C. Is it in A? So is C a subset of A? Yes. So be true. Then it says C is not a subset of B. Well, let's put B down here. B is 5, 10, and 15. So if C is not a subset of A, everything in C is not an A. Well, actually, everything in C is not an A. Like, there's nothing in C. That's an A. C has 6, B has nothing. C has 12, B, nope. C has 18, B is. So the moment that one of them is not in the other is it's not a subset, right? So the moment I said C has 6, B doesn't, I'm done. I don't even have to check the rest, do I? Do I have to look at the other numbers? Nope. The moment one of them is not in the other, you're done. It's not a subset. So this is true. Now we're comparing complements. Well, to compare complements, you should maybe have both complements. So I have complement of A up here. I'm going to do complement of C as well below it. So the complement of C is all the numbers that are not 6, 12, and 18. So I go 1, 2, 3, 4, 5. And like some people can visualize and not write it out, most people will get a number off or wrong. Okay? So I always write them out. 1, 2, 3, 4, 5. 6 is in there. 7, 8, 9, 10, 11. 12 is in C. 13, 14, 15, 16, 17. 18 is in C, and then 19. I always write them all out. Those few seconds it takes is worth not getting the question wrong. And you have lots of pencil lead at the beginning of the year. Okay. So we want to know, are all the values in not A in the complement of C? Complement of A in the complement of C, because this is a subset, right? And remember, if you forget what that symbol is, it's on your formula sheet. It will tell you it's a subset. So is everything in not A and not C? Okay, let's check it out. Not A has 1, not C has 1. Not A has 2, not C has 2. Not A has 4, not C has 4. Not A has 5, C has 5. Not A has 7, not C has 7. Not A has 8, 8. 10, 10, 11, 11, 13, 13, 14, 14, 16, 16, 17, 17, 19, 19. Is not A a subset of not C? Is that a true statement? Okay, we have till 10:28, so I'm going to have you guys, I don't have enough workbooks. You're not writing in these workbooks anyways, but if you want to work by yourself, grab a workbook by yourself. If you want to work in a pair, grab a workbook in a pair. I don't have enough for everyone, so I hope there's some people who want to pair up. The only thing I ask that you pair up is that you work, because if you don't work, I'm going to come over and make you work. I don't want to be that. You're adults, right? You can almost vote. Some of you can, okay? Go get yourself a book. We're turning to page 12. Everyone's turning to page 12. You guys can move your desks beside each other if you're sharing. Just move them back after. What I need you to do is you're going to look at page 12, number 1. I want everyone to answer it. Do A to E and go. And we'll discuss it. A to E and go. Number 1. So page 12, you're working on number 1. Now, as you work on it, you can check the answers. They're behind each section. Like right behind that section. They're not in the back like a textbook. So at the beginning of class on Monday, you're just going to grab a workbook right away at the beginning.